We're all set. Okay, we're going to start soon. Um, okay. We'll give it a couple of minutes so people can join. And yeah, so I think let's start on time since you have five uh, excellent presentations that we will be seeing in this session. So, hello everyone. Welcome to the this session of ICSI called Search Based Software Engineering 3. It's my pleasure to have five exciting talks today that we'll be seeing, in which one of them is actually nominated for the Distinguished Paper Award. So, without further ado, we can start with the first presentation.
All right. Hello, everyone. I am Abdul Ali Bangash, and I'm a PhD student at the University of Alberta. Today, I'm here to talk about my paper in which I propose a black box technique that can be used to reduce the energy consumption of Android apps. I've done this work in collaboration with Karim Ali and Abram Hindel. First of all, I would like to talk a bit about the motivation behind my work. So, current literature suggests that battery is a huge concern for the smartphone app developers because if an app consumes too much energy, it gets bad user ratings on the App Store, it gets lesser downloads, and it eventually hurts the profit revenue. This concerns the developers. So, now the developers want to develop energy efficient apps by employing various energy measurement and optimization techniques. For measurement and optimization, there are hardware based techniques available for the developers, and also there are some software based techniques available. However, both of these techniques have certain limitations. The hardware based techniques are hard to learn, hard to set up, and aren't cost effective. Alternatively, there are software based techniques available, but for these techniques, developers have to root their phones, generate and execute test cases to collect dynamic traces. As a solution, we investigate if we can optimize the energy consumption of an app during the Android compilation process. First, I will explain how the Android compilation process works. The source code written in Java is compiled by the Java compiler into Java bytecode. Then an optimizer performs bytecode level transformation to further optimize the bytecode. After that, a DEX compiler converts bytecode classes into DEX bytecode, and finally, an Android APK packager packages this bytecode into an Android executable format that is called an APK. We investigate if the bytecode level transformations that the optimizer performs can be used to optimize energy consumption or not. To investigate the effects of bytecode transformations on energy consumption, we consider a random set of four bytecode level transformations that were initially written to reduce the Android's app size and improve an app's runtime performance. When we applied these transformations on 22 real world Android apps, they reduced the energy consumption of 12 out of 22 apps by up to 1.24%. To further investigate, we use the Facebook's Redx bytecode transformation framework. This framework offers 17 transformations that are mainly written to reduce the app size and improve runtime performance. Some of the transformations out of these 17 are constant propagation, dead code elimination, method inlining, and so on. However, for applying 17 transformations, we have to consider all of their possible combinations. That means 2 power 17 possible solutions. It is exhaustive to measure the energy consumption of 2 power 17 solutions or Android versions or variants to find the best variant. Hence, applying all possible combinations of 17 transformations is impractical. As a solution, we explore the search space of 2 power 17 possible solutions using genetic search. Initially, we randomly select transformation combinations to generate an initial population of solutions. We then measure the solution's energy consumption to select most energy efficient solution from the search space. After that, we apply crossover and mutation among the best transformations for the next iteration. We keep repeating this process for 10 iterations if the solution stops improving and for 20 iterations at max. At the end of this process, we get the most energy efficient transform version of the original Android app. We applied this technique on 4 real-world apps to evaluate its effectiveness and saved up to 11.05% energy among 2048 game, Chrome browser, a 1.15% reduction we achieved for Chrome browser, 0.42 reduction for Anagram utility app, and 1.79% reduction for the Paint utility app. To conclude, I would say the developers want to build energy efficient apps, but there are several limitations in the current techniques. As a solution, we propose a black box technique that developers can use to reduce the energy consumption of their code when applied on real world apps. Our technique reduced up to 11% energy consumption. In future, we want to investigate about the reasons behind the bytecode transformations that led to energy reduction. We want to apply multi-objective optimization so that we can reduce app size, improve runtime performance, and also reduce energy consumption at the same time. And using the current studies dataset, we want to train a prediction model which could predict the best transformation combination for a given Android app. That's all. Thanks a lot for listening.
Okay. Can you see my slides? Can you see my slides?
Yes, we can.
Yes,
Okay.
Maria. Yeah. Thank you, Hadlari. Thank you, Maria. You can start. Thanks.
Okay, thank you. Hello, my name is Maliha Izadi, and I'm a postdoc researcher at the Technical University of Dove. In this talk, I will provide a high-level overview of our recent work on automatic code completion. This is a collaboration with Roberto Gismondi and Dr. Georgios Gosius. As a developer, you most probably have used some sort of autocompletion while programming. In fact, research has shown autocompletion is one of the top features used in IDEs. Autocompletion refers to the task of completing source code by predicting what the developer would write given the current context. Traditionally, IDEs use rule-based autocompletion. It means that they would sort their suggestions based on alphabetical or usage order. As you can guess, this isn't a very accurate solution, and often it would defeat the main purpose of autocompletion, which is to save developers time. To improve the accuracy of autocompletion, and thanks to the availability of vast amount of open source code data, researchers have started using learning-based models to learn from data. But they initially treated source code as natural text, ignoring the rich structure of source code. In this work, we aim to learn from both the natural sequence of tokens and the structure of code. To do that, we use the MTL technique. Researchers usually train models to optimize for a single objective. With multitask learning, we aim to optimize our learning model for multiple objectives at the same time, hoping that the model could learn from all of them. In our case, we define three pre-training tasks. The first task learns from the normal sequence of tokens, such as variable names, functions, etc. in the first picture. And this enables relationship among token values. Our second task is to learn from source code structure, which we represent with a one-to-one correspondence between token values and token AST types as represented in the second picture. This helps the model to learn association between syntactic elements of code. As we are also eager to learn from name dependencies across longer ranges, we added the third pre-training task, which is completing code statement at the value level. Here's an overview of how we train our model. As I already mentioned, we have three tasks. Each of these tasks have their own deep model. And the underlying architecture we use is a generative pre-trained transformer called GPT-2. And we share the representation among all of them, and the loss is also shared among all tasks. So far, we focused on training better models for predicting source code, but we also wanted to assess the models in a more practical way. So in addition to evaluating the models when they predict a single next token, we also assess them when predicting different type of tokens, such as identifiers, keywords, etc., or when completing statements. So this is the research questions that we define in addressing three aspects: token level prediction, a statement level prediction, and an ablation study. So we defined 5 setups, and code field was able to outperform the baselines in all of them. But given the time limit, I will only report the results of 2 of the baselines next. 2 of the settings next. When we are coding, we usually trigger the auto-completion at specific points, such as after a dot or after an opening parenthesis. We call these points cardinal points. To ensure that the prediction translates to practical benefits for developers, we assess the performance of code build for predicting at such point. And we show that it can outperform the state-of-the-art models by a relatively large margin. In our statement completion task, we address longer predictions. In practice, many developers may prefer that autocompletion suggests tokens up until the end of a statement. So here we compare the models for predicting next n tokens, and n is the range of 2 to 8 tokens. We can see that all of the models' performance drop as the number of tokens increases. However, Cloudfield, shown with the pink line, is able to outperform all other models by a large margin, and this margin grows wider as the number of tokens increases, especially in the Rouge case. This highlights the importance of the statement completion task we included in our approach. Here are the key insights we got from this work. We learned multitask learning is a promising direction for training stronger language models. It showed that including a structure in the process of learning can boost the results, and we also found that learning to complete statements can be a good pre-training task. As the current models can predict a single next token with a reasonably good accuracy, it may be more worthwhile to focus on other aspects of completion, such as longer completions. Another aspect is to provide better evaluations. We believe that it's time to design assessment setups that resembles the need of developers in practice. Perhaps we should focus on predicting and evaluating for a specific type of tokens, or maybe we can come up with better metrics tailored to source code generation. If you need to know more details, please take a look at our preprint or come talk to us in the in-person conference. Thank you.
Thank you, Maliha. So next presenter, please, Saeed.
Sure, that's one second. Okay. Hello everyone. Today I'm going to talk about fairness-aware configuration of machine learning libraries. Data-driven software is growing fast and has pervasively applied in critical domains such as self-driving car and socially critical applications. They have been using criminal justice to make parole decisions, in hiring to filter out candidates, and for various risk assessments. Since these applications learn their logic based on historical data, they are prone to fairness bugs. Therefore, it is critical to ensure fairness in such application for compliance and inclusion. These data-driven software often provide interface to programmers to interact with core machine learning libraries such as scikit-learn to feed input dataset, as well as configure machine learning algorithms with suitable hyperparameters. Hyperparameters include the number of layers and neurons in deep learning, the number of depths in the decision trees, and the number of clusters in algorithms such as k-means. These papers study the relationship between hyperparameter selection and fairness. We answered 4 research questions that I am posing right now. Whether hyperparameters affect the fairness of data-driven software. That's research question 1. Research question 2 studied whether principled search-based software engineering can help us find interesting inputs. Research question 3 study whether statistical debugging can help us understand the rule of hyperparameters. And finally, research question 4 compare our approach to the state-of-the-art for mitigation. To answer this question, we propose a 2-step method. First, we use an evolutionary algorithm based on mutation operators to search the space of hyperparameters and characterize the accuracy fairness frontiers of hyperparameter. Then we use statistical fault localization to explain what hyperparameters are similar in the fair models and what hyperparameters distinguish biased model from fair ones. To overview our approach, let's consider random forest ensemble with 18 hyperparameters, such as the max depth of the tree, and a data set of adult census income that predicts whether an individual has an income over 50K or not. We use sex as a sensitive attribute first. We run our search algorithm for 4 hours and characterize the inputs. We measure fairness based on EOD, which is equal opportunity differences. And basically, it is the differences in true positive rate of two groups, in this case, male versus female. And we consider overall accuracy. So we wanted to know, using decision tree, are there any hyperparameters that achieve similar accuracy, but their fairness metric is different? We did the same experiment using race and generate the input and explain the differences between two clusters of the fairness inputs based on the decision tree. The phenomenon was that mean weight fraction leaf that restrict the number of sample in the leaf node of decision tree or random forest can negatively impact fairness if it sets to value greater than 0. And max feature, which restrict the maximum number of features to search during training, can also negatively impact fairness if it sets to square root or log2 base a number of the features. Now, after overviewing our approach, let's come back to research question 1. We found that indeed tuning hyperparameters impact fairness. Within a 1% of accuracy margin, fairness can be below 1% or above 23% based on the hyperparameter tuning. In research question 2, we found that a classical search-based algorithm such as evolutionary mutation-based is effective and outperform random search or grid search. And research question 3 found that decision trees are useful. We analyze over 900 decision tree models and provide intuitive explanation if any hyperparameter systematically influence fairness. Finally, research question 4 found that our approach can be also used as a bias mitigation method, and it can complement existing methods to achieve even better fairness. This is end of my talk. Thank you for listening. The tool is available in the following GitHub repository, and it's already received badges from Artifact Evaluation Community. Thank you.
Yep. Thank you, Saeed. So next presentation.
Yep. Okay. Hello, everyone. I'm Donghan Shin, a research scientist, University of Luxembourg. And today I'm going to present our recent work about efficient online testing for DNN-enabled system using surrogate-assisted and many objective optimization. This is the work done in collaboration with our PhD student Hitachi Hawk and Professor Lionel Briand. DNN-enabled systems, or in short, DES, are widely discussed, and nowadays it's very familiar with us. For example, if we look into the self-driving car, we can easily find that there are some DNNs, very essential for example, object detection, lane detection, and so on, to deal with high-dimensional data, such as images. Such a DES often operates in interaction with its application environment. For example, the self-driving car should be able to continuously read the driving environment, surrounding environments, and generate adequate driving commands to best drive the car without making any safety violations. And this is exactly what we are going to do using online testing for the DES. However, there are several challenges we have for online testing. First of all, the input space is too large because we can think of many different driving scenarios to test. At the same time, there are several safety requirements to be considered. And then there is a huge bottleneck, which is the simulation, because the driving simulation is often very computationally intensive, meaning that the fitness evaluation in our context could be too expensive, so that we cannot simply apply the existing search-based approach in this case. And also there are some third-party components in which we cannot access the source code nor the internal information about that. So yeah, to address those challenges, we propose Samota, a black box online testing approach that combines surrogate-assisted optimization and many objective search. So I want to remind that, in general, search-based testing, we compute many fitting scores because there are many candidate solutions generated during the search. But the idea of surrogate-assisted optimization is that instead of using very computationally expensive simulations, we build and use surrogate models that can efficiently predict the fitting scores. And then only the best predicted test scenarios found by the search using the surrogate models are evaluated through the expensive simulations. And the result will be, again, used to build more accurate surrogate models in the next iteration. So this is the idea of surrogate-assisted optimization. And on top of that, following the state-of-the-art, we leverage two search phases, global search and local search. Briefly speaking, global search first explores the search space, and then the local search exploits the promising areas found by the global search. To do this, unlike the global search that uses all the data points in the database, a local search begins with clustering the top n data points in the database, and then generates one surrogate model per cluster. This allows the local search to better exploit the most promising candidates in a very specific area. So our case study used Pilot, a DES, deep learning enabled system composed of multiple DNNs and other components for self-driving. And we also use COLOR, a high fidelity driving simulator that is widely used in the research community. Using that case study, we found that our clustering-based approach can actually indeed significantly improve the efficiency and effectiveness of the local search. And on top of that, our approach Samota is indeed significantly more effective and efficient than its alternatives like Ftest or MOSA that are used for many objective test regeneration before without using the surrogate-assisted optimization. So that's the result in a very summarized form. And of course, you can find more details in our paper as well as our full-length video. So feel free to find more details. And of course, you can contact me if you have any question. I'm very pleased, happy to discuss with you. Thank you very much.
Thank you, Dong-Hwan. So just a reminder for the audience, please feel free to maybe share your questions also in the chat. This way, the authors may actually have a moment to think about them before we start the discussion soon, since we are having now our last talk for the session, which will be done by Matthias.
All right, you can see the screen. It's not flashing. Can you hear me as well? All right. Okay, let me just switch one more thing. There we go. Okay, so welcome to this talk. My name is Maddie, and I'm at Chalmers, and I'm joint first author with Leonard at Delft, and this is work in collaboration with Annabelle, Ari, and Dave. And I'm going to present to you Proper, property-based automatic program repair, right? So what is Proper? Well, Proper is our way to address some of the challenges that we face in program repair, right? So first of these is overfitting, right? So a lot of program repair uses unit tests, which are, these input-output pairs, and the program repair tends to, focus on fixing it just for those unit tests, right? And then like you fix it for just that input, but it doesn't really generalize to other inputs, right? So we want to address that somehow. Another thing that we address is the limited search space that program repair tools have. So a lot of them, like, they use code patterns and they use existing code bases to learn and figure out what might constitute a repair. But this can be, bad if you need to come up with something novel in order to fix the bugs. One thing that we address as well is the heavy use of frameworks and metaprogramming libraries. So we see this especially in the Java world. There will be lots and lots of libraries and frameworks to parse the code, instrument the code, and do all of the groundwork, right? But these can lag behind when Java is updated, right? So we want to address that somehow. And then finally, like a common challenge in program repair is if you have a lot of local solutions, you want to somehow generalize those to, or like you have a lot of local solutions and you have you want to combine those to kind of fix bugs in multiple places, right? So you can fix the whole program, not just parts of the program. Okay, so how do we address these? Well, the proper way to do it, as we say, first we start off with property-based testing. So property-based testing is something that was kind of innovated in QuickCheck in Haskell, and it's a way of defining test cases, right? So instead of giving a couple of input-output examples, you define a property, right? So here you can say that for any list, right, the applying the reverse function should return the elements of that list in reverse order, right? And of course, this means that if you can't just overfit on just the inputs and outputs, because it's a lot harder, right? Because you actually have to fit through the property as well. But of course, you can still overfit on the properties, but it's a lot harder, right? We use type-based synthesis to extend the search space. So in Haskell, we have a strong type system. So we have a specification of, a very strong specification of what the code should be able to do. And this allows us to use type-based synthesis to kind of generate novel programs to fix bugs, right? So we're not just limited to things that have already been written before. So this is a big win, right? We actually integrate with GHC itself, like the Haskell compiler. So the instrumentation, the parsing, the compiling, it's all done by the compiler itself, right? So this means that when there's a new Haskell version, we just have to update it for the new compiler, right? And we don't have to update all the libraries. So this allows us to, there's a lot less maintenance burden on us. And then we use genetic search to kind of combine partial solutions, right? And this is the things that have been done before, but we have islands and tournaments, a lot of fancy genetic search stuff to combine them, right? So some results. Well, we have the we perform all right with respect to where frameworks are usually at this point. This is our first publication. So what we did was we have the kind of a couple of baselines, right? We have the exhaustive search that it's basically to test whether we can find a solution. So it just tries out everything, right? We have the random search that just tries things at random, so it doesn't actually like go through. It just picks something to test out, and that doesn't work so well in our case because with the type-based synthesis, the search space becomes a lot bigger, right? So the method we're championing is kind of the genetic search, right? And that works a lot better. It's a lot faster than the exhaustive search, and it actually finds most of the bugs, most of the fixes, right? So it's quite good, right? And another discovery that we made is that if you combine unit tests with properties, that's actually the best, right? So if you have the unit test to kind of check the edge cases, and then you still have the properties to make sure you're not overfitting, that actually works great, right? Okay, so that's all I have time for to present for you today. If you're interested in how we do it, I recommend you check out the full talk. And me and Leonard will be here. We're on Twitter, and we'll be on at ICSI as well. If you have any questions, and then you can play around with the source code, and the artifact is also available attached to the paper. All right, so that's all I have for you today. Thank you.
All right, thank you, Matthias. And this ends the presentations for today's session, and we are now open for questions. So if you have any questions, please feel free to either ask on the chat or just speak to these presenters. Questions?
Maybe one question to Abdul. So how do you make sure that your method are free of side effects and also possible security issues after transformation? So I mean, like functionally, you don't change by doing those optimization for energy.
Okay, I'm sorry. Can you repeat the question, please?
Sure. I just ask about how do you make sure that your approach is free of side effects? Basically, it doesn't change the functionality of the program that you compile by transformation to improve the energy.
Yeah, so to make sure that the transformed versions are semantically correct, we basically have a pre-existing set of test cases which we execute every time after the transformation. So those test cases, if they're successful, it means that the application is good enough. Unfortunately, it is dependent on the set of test cases. So it completely depends on how much the application is being tested with those test cases. But there could be some blind spots which could, go unchecked, and it might break the semantics over there. So the semantic correctness is dependent on the set of test cases which we have.
Thank you. That makes sense. Yeah.
Plus, I believe it also inherits perhaps all the limitations of all these frameworks of transformations, right? So I don't think the authors are checking thoroughly whether these transformations are, preserving these kind of non-functional requirements, right? It's like security and everything. But yeah,
Mhm.
but Abdul Ali, I have another maybe follow-up questions to this. When you create all these different combinations, you are making a hidden assumption that these transformations are independent, right? This way you can actually combine them in different ways, right? My question is to what extent this holds. What I'm saying is, would you be able to see in your search that you generated unfeasible solutions because these transformations in this order don't make sense?
Yeah, so the only way we had to check that was whenever a test case fails, or sometimes the application would completely black out. So we just, cross out those variants out of our search space. We just
Okay. So you just cross them out without necessarily checking why this is happening. You just cross them out and keep moving. Okay. Okay.
Mhm,
That answers my question. Thank you. Any other questions with the presenters?
So one of the question here is that why I chose the bytecode level for the approach. What are the anti-patterns? So the reason for choosing bytecode level is um, currently most of the approaches, as up to my knowledge, all of the approaches um, they do certain changes in your code
Mhm.
to refactor your code so that it could be optimized. But if we do it at bytecode level, it's going to keep the developer's choices. So if you go and look into the literature, you have to apply certain design patterns in your code to improve the energy consumption or change certain properties, which affects the maintenance of your code, maintainability of your code. But if you do it on bytecode level, then you get rid of these kind of side effects.
Yeah. Which reduces the overhead of maintaining the code. Yeah. Yeah, makes sense. Thank you, Abdul Ali. So we have a next question from Abdul Ali actually to Don Juan, which is,
Yeah.
how do you identify the fitness of the generated test case? Did you have a pre-existing data set to compare with?
Yeah, actually, I can see two different questions. So the first question is about how to compute the fitness score of the test data we generated. Yeah. So basically, in our case study, that is about the self-driving car. And then there must be some safety requirements about the driving situation. So, for example, the self-driving car should not collide with other vehicles, should not hit the pedestrians, should abide by traffic lights, and so on and so on. So we have 6 different safety requirements, and for each of them we can actually measure, we can compute the fitness score as a function. For example, for the collision thing, we can measure the distance between the cars, so that if the distance is smaller, then it means the fitness score should be higher, so that we can provide some guidance of the search algorithm so that the search can generate more critical test cases. That's the way to calculate the fitness scores. Of course, that requires the actual simulation, which means very computationally expensive. And that's the reason why we were trying to use the surrogate models. And then the second part is how do you have any pre-existing data set? Yes. So we do not have a pre-existing data set. Of course, we are very relying on the simulator, and we can generate some pre-existing data set using the simulator. It is possible, but in our case study, we did not generate any pre-existing data set from the beginning. However, in one of the evaluations, we actually use the data set generated by the previous session of the execution of Samoto approach, which just to assess what if we provide non-empty data set as an input of our approach so that the surrogate model can be more accurate from the beginning. So what was the impact on that? That was one of our research questions. You can find more details in our paper. I hope that answers your question. Thank you.
Yeah. Don Juan, thank you for your answer. I have another follow-up question.
Sure,
Why
please.
many objective optimization, right? So, because when you have multiple sources of information, does that necessarily mean that you have a conflict?
Well, yeah. First of all, money objective, multi-objective, because we have multiple safety requirements to be considered at the same time. It's like, the car should not collide with the other car, and at the same time, the car should not, collide other pedestrians, and it should abide by the traffic lights and so on. And those safety requirements are something that we have to consider at the same time. And there is another reason. If we consider each of individual safety requirements one by one, then we can somehow, run the same approach multiple times for each of the safety requirements. It is possible, but that's not super efficient if you think about the case where some safety requirements cannot be violated at all. For example, let's say there is a safety requirement that cannot be violated at all. And if that's the case, then you basically, waste whole time budget pre-allocated for that safety requirement. However, if we use a many objective search algorithm, then the search algorithm internally, handle this kind of situation and put more effort to the other safety requirements that can be violated during the time budget. So that's the reason why many objective search can be more efficient compared to single objective with multiple executions, multiple separate executions.
Yeah, my thought is this, because some of these objectives, yeah, you're trying to find a trade-off between them, but I guess some of these objectives might be more, I'm not going to say maybe more critical than others. And if you are maybe sacrificing some of them, you are maybe creating a more dangerous, or you are skipping a more dangerous situation than you may want to account for, right? So it's an interesting area of observations that, yeah, you can actually look at. So
yeah, thank you. You're right. I mean, we cannot easily assess the criticality or importance of individual safety requirements, but if we have somehow that information, then we can do more using that kind of, let's say, domain knowledge. So
true. Plus,
that is true.
many objectives typically tend to be slightly more expensive to execute, right? And this is a kind of a safety critical application, right? So so how would you handle that expense if you experienced such expense?
Yes, that is expense. I mean, definitely many objective must be more expensive than single objective like single GA or simulated annealing. That's for sure. But in our case, the actual bottleneck is not the execution time of the search algorithm. It's more about the simulation time. So because the simulation takes most of the time, and reducing that is more important than reducing the execution of the search algorithm per se.
Makes sense.
Yeah. So in our case, we use the surrogate models to reduce the simulation time. Yeah, that actually works well. So yeah, we were happy to report the result in the paper. Yeah.
Awesome. Thank you. Makes sense. Thank you very much. Yeah. Any other questions? Maybe I have a question from Maliha.
Okay.
You came at the right time. So based on Saeed's presentation, I'm like, how did Maliha ensure fairness when she's comparing all these different models, which are not easily, configure it. Look at them. I'm like, wow, a lot of combinations, a lot of deep learning models. So how would you ensure fairness between them when you were comparing between them?
We use the replication packages to stay true to how the authors have developed their models, and also for statement completion, because several of these deep models weren't trained for statement completion. We try to modify it to also be able to predict for the statement completion. And yeah, that's it. And our measure was accuracy in different settings. So we also try to see when they are predicting any token or when they are predicting different type of token to provide a more comprehensive evaluation, be fair between them. But other than that, yeah.
Yeah, tweaking them to do more than just statements is it's a bit I guess a bit tricky, right? So
Yeah.
I can see that. Yeah. So maybe Saeed, if you want to maybe comment on how you provided this framework, how your researchers can right away use your model to reduce bias when they're performing comparative studies.
I think that's a good question, and the different angles. So I look at like how fair is this for different basically society groups, but looking at actually comparison with baseline or state of the art. That's your question, right?
Yeah.
And I mean that is like usually different questions. So what we try to do, at least my work, I can basically comment on that. So I try to like repeat every experiment 30 times, use like same underlying system for both of them, measure not only mean but also 95% confidence interval. So I did these things to make sure that fairly comparison with the state of the art. But in general, that is a bit different than looking at the fairness in socially critical domains like a parole decision and so on, and how to make sure that you give a similar treatment to, for example, African American versus white or male versus female in decision based on the machine learning system.
Yeah. Thank you, Seth. Plus, of course, the tuning of the algorithms. We should ensure that they are all not being using default and they're using their best optimal tunings. And when authors provide replication packages, this makes the life of researchers way easier for them to do that. Yeah. Thank you.
Yes.
Maybe we haven't heard from Matthias. So, Matthias, maybe I have one question for you. You motivated your solution by saying that you're addressing overfitting on passing tests, and also you're addressing it, by reducing the limited, search space. But someone could argue, but these are the main common problems that are recurring all the time. And me as a developer, I care about these more than what you called novel but corner cases, right? Would that be maybe an argument? Like if you, I mean, a developer for myself, I care about the case that I know that developers would always have this kind of recurrent errors, right? So having those being repaired properly is my goal rather than looking at just corner cases. How would you address that?
Right. Yeah, I mean, so the thing with edge cases is that they might be a class of edge cases, right? Like it's not going to be one input that's the edge case. You might have a million inputs that are all edge cases, right? And the trick with the property-based one is that it like you can actually define the generator, right? So you could actually make sure that it's generating the interesting edge cases mostly, right? And I mean, and the trick is that we don't just want an if statement that says, if it's an element, like if it's a list with a million elements, do this, right? Because you want to be sure that you're not too specific to the tests, right? Because you want to actually fix the program, and the tests are just a model of what the program should do, and they're not really what it should do, right? It shouldn't just pass a test; it should actually do the right thing, right?
Okay. When I was looking at your paper, I was thinking that the property-based, it does not necessarily compete with existing studies, but also it can complement them in some way. Do you see it that way as well?
Yeah, that was what we saw, right? That if you combine unit tests with properties, that performed best, right? So
Mm.
we want to, we already have the unit test for like things you were trying out when you were writing it, right? But the properties are also just to make sure that if you change something and it might still work for the unit test, but maybe you introduced a bug in something that you didn't cover, right? And the properties are just a way for you to specify a lot bigger, so one property is generating 1,000 unit tests, right? So you don't have to do that yourself, right?
Yeah.
So they
Yeah, that's
definitely
awesome.
complement each other. Yeah.
Yeah, that's awesome. Awesome, Matthias. Thank you. Thank you.
Thanks.
Any other questions?
Question for Saeed.
Yeah, Malia, yeah.
In your study, you investigated different classifiers. That's a very good sign. But did you also investigate deep models? I mean, does your approach extend to deep models?
And this is a question to
Saeed.
Saeed.
Um, I guess so. That is a question to me, but I didn't want to make the. Yes, it can in principle, but I think we need a bit more kind of efficient way to explore that space. So training in those spaces is a little bit more expensive. So like how you want to basically change carefully layers and neurons and so on and measure those metrics is a bit challenging compared to that. But there can be some approximation. So like one idea is to approximate those systems with standard classification. Especially one of the things that I wanted to mention before answering correctly is that in fairness, there is a contradiction between using fairness and deep learning because deep learning are not interpretable
Yes,
and not
exactly.
explainable. So now how you like there is a tendency to not use deep learning, at least at the current state. So that's why a little bit contradictory to even try to do that. But anyway, it might be used, and one idea might be to use some interpretable model to approximate them, like decision trees or combination of decision tree with SVM to have a larger space, and then use these kind of techniques. But going back to deep learning testing, this is another like a domain, how we can efficiently test like different property on deep learning environment. And that goes back to, I think, Sheen's talk and the way that they define and they try to efficiently explore those spaces. So that is a little bit different. The same methodology that I use might not be directly useful in deep learning. So you need some tricks or some techniques to perform search strategically, basically. I hope that
Thank you.
answers the question.
Yeah, thank you.
So Saeed, if I correctly understood your answer, would I be able to take, for example, one deep learning model, let's say CNN, and you have, for example, let's say you have a binary classification problem. You have one CNN, you have, here decision tree or random forest. Would I be able to look at the overlap in their confusion matrix, like where they are agreeing, where they disagree, and do the same study to kind of extrapolate what I found in the random forest and explain how the CNN performs? Is that what you meant we can do?
Yes, so the underlying technique can be similar because there is a configuration options there as well, but they are also a little bit fundamentally different because they have different power of the prediction.
Yeah.
So what I suggest here to do this search on the configuration space, basically some kind of approximation that we take those, first of all, for interpretability, we take those systems and represent them with some other system, and then try to understand and study fairness based on them. So that is basically the idea. But like they are, going back to your point, they are similarity. Like we found that, okay, restricting decision trees might negatively impact fairness of the underrepresented communities. Same way, maybe in deep learning, maybe similar like type of or similar some architecture might lead to systematic bias if you use that, especially if you have a lower representation of a particular community. So they are like finding from my paper was that there are some hyperparameters that can systematically impact fairness in beyond one particular training data set. But this might be the case for deep learning as well, but I don't know at the moment the answer for that.
Yeah. Thank you, Said. Yeah, makes sense. Makes sense. Thank you. Any other questions? Maybe I have one for Abdul Ali. I haven't heard from you in a while. So you mentioned that you are looking at in the future to do some multi-objective optimization, right? So, and for me, I'm not sure exactly how you want to do that. Are you foreseeing some kind of conflict between performance or size, or are you trying to achieve the same kind of performance optimization with less usage of frameworks? So, what exactly would be your multi-objective setting?
That's actually a very good question. I'm not sure right now if our energy optimization was in conflict with size reduction and performance improvement in terms of runtime. But if it is not in conflict, then it's a win-win situation. But we haven't evaluated that yet. But if it's in conflict, then it's a multi-objective optimization problem, because in Android, people want to reduce their app size as much as they can and improve their runtime performance as well. So we have like 3 parameters in hand. And then one you also measured, like mentioned in your previous question, which is security. So yeah, these kind of parameters, if we want to improve them simultaneously, we have to look at the multi-objective problem. Yeah.
Yeah. Yeah. I mean, if the conflict exists, because
If
maybe
the
size and
conflict-
performance,
if it
they
doesn't
may
exist,
go
yeah, we
they may
have-
go along, and this you are winning because now you're using yeah. So to avoid having a trade-off, yeah, that would be
Sure.
better if they're not conflicting. So always analyzing whether there's a conflict or not first would be always a good idea. So yeah. Thank you. Any other questions?
I guess there is another question. Could we decompile after the bad code?
Mhm.
Better understand.
Oh yeah.
Yes, we can. Yeah, because it converts the text code, and then we can decompile it to Java, and then investigate that what were the changes that bytecode transformations made. Actually, I have done a little bit of research on this. So I basically there are some object-oriented metrics, code metrics like the CKJM and mood metrics. So we actually extract those metrics and identify how that bytecode transformation affected those metrics, so that we can find out what were basically the effects of bytecode transformation and why the energy actually got reduced or increased. So yeah, it could be decompiled as well, and after decompiling, we can also extract those kind of metrics to investigate and see what the effects of bytecode transformations were.
Yeah, I see this to be an interesting empirical study where you look at the impact of these transformations on the structural metrics, and then this would perhaps tell you whether these transformations would conflict with design principles in general or not, right? So yeah, that would be a cool empirical study to maybe perform. Yeah.
This actually brings me to answer the previous question from Dong Quan. They asked me about the anti-patterns. So yeah, once we investigate that kind of behavior, that why bytecode transformations and what did the effect on the code structure, we can actually identify those anti-patterns for energy consumption. I'm actually not working on this project right now, but if someone wants to collaborate, for sure, just go ahead, send me an email. Yeah.
Awesome. Good. Thank you.
I also have a question for Abdul.
Mhm.
In your study, different transformations to different applications, and you saw that they
Sorry, I guess you got cut off in the middle, so I didn't.
Okay, let me say it again. I think that you applied different transformation to different applications and observed that they are affected differently. So, for
That's
example, a specific transformation affects different applications. It can cause the consumption to go up or to go down. But did you also investigate to see if there is any correlation between the category of these apps with these effect in their transformation, in their consumption?
We haven't, but yeah, that's a very interesting point, and we can actually do that because unfortunately we weren't able to identify a single transformation which unanimously affects these similarly to on all applications. But probably if we divide them by category, it would be interesting. Yeah, we might be able to find some transformations which are always good enough for those categories. Yeah.
Good, thank you.
Thanks for that. Yeah.
Thank you. Maliha, since you're here, let me ask you this question. So you mentioned that in the future you want to handle longer predictions, right? Or longer sentence predictions, right? So what are the changes you foresee for your current solution, or you think it's just ready for that So
I think that we need to make some architectural changes so that it could understand the longer ranges and process them better. And another thing would be to use context in a better way. For example, should we feed our model with the previous file or the whole class or only the nearest scope? And I think we should experiment and see if they can help it.
yeah,
Improve it.
makes sense. Yeah. Thank you.
Sure.
Any other questions? The audience? Questions, guys? Say.
Yeah, I have a question to Shin on his work. You mentioned that you're using different clustering to local. So how do you choose? I mean, there's always a question of exploration versus exploitation. How you choose trade-off between them?
In that clustering part, you mean?
Yes.
Okay. Yeah. For sure. I mean, deciding the number of clusters in advance is kind of tricky problem, and we don't know how many clusters. Basically, the cluster means each cluster means a promising region in the search landscape. So we don't know how many promising areas are there in advance. However, what we can do is we can somehow set the maximum number of clusters as a threshold, and then we can do some hierarchical clustering to build a reasonable number of clusters, and then starting from there, because even though we do not know what is actually very promising area, but what we can do is we can at least try to gather similar data points if they are reasonably close to each other. So the idea of using the clustering is, instead of using all the data points in the data set, we cluster them, and then for each cluster use the surrogate model, generate the surrogate model for each cluster, and do the local search for each cluster. Of course, this means that we need to repeat the surrogate model generation and search for each cluster may increase the time, but as I said before, this is not a problem, because in our case, the time consuming part is not the search or surrogate model generation. It's more about the simulation execution. So that's the reason why we choose to do this. If you want, you can also increase or decrease the number of clusters by setting the parameters for the clustering, but that's what we didn't do in our evaluation.
All right, that makes sense. Thanks.
Thank you.
Makes sense. Any other questions? If not, I want to take this moment to thank all our presenters, and I want to thank the audience for their questions. And yeah, this concludes perhaps our today's session. Thank you all for these nice presentations, exciting presentations, and yeah, hopefully you have enjoyed the session. And with that being said, so thank you very much, and I'll see you around. Thank you. Bye bye.
Thank you.
Thank you, Mohammed.
Thanks.
Thank you, Mohammed. Bye.
Thank you. Bye bye.